Okay, so welcome to this video, and we about to try and understand the chain rule for partial derivatives. So now we've been given to say find dw over dt using the chain rule for partial derivatives. So how do you do this? So depending on how many variables, of course, which you have that you're dealing with, but generally you're going to say that you're going to say that the dw, this is going to be dw over dt, and this is just going to be, so you take partial of x of w with respect to what, to x, so the partial of x there, then you're saying d what, dx over what, dt, then you add, that is partial of w over what, partial of x of y, then dy over d what, dt, uh, plus partial of w over partial of z, then dz d over what, dt. So this is presuming that I have a function, because okay, in this question which we're dealing with a function that is w. So I have w, and it's defined in terms of what, of these functions, that is x, y, and z. Then I have these functions x, y, and z. They are also defined as what, as functions of, or they are written as functions of t. So each of them have been written as a function of what, of t. Hence we are doing the d what, dt, dt there, like that. So now, in order to find this using what, the chain rule, we're gonna use question part B. We use part B as our example for this one. So now, what does that mean to us? So if you see part B, what we've been given, w is just tan inverse of what, of y over of yz over what, over x. Then you have now y, so you have x being written as a function of t, but then it's t squared. Then you have y being written as, that is t cubed. Then you have z as z1 over what, t to the 4 to the fourth. So you have them like this. So now what does this demand of us? You need to find this partial here. You need to differentiate like this. You need to find all these what, all these components, but you can easily find this. So first of all, let's go, we find partial of w, partial of what, of x. What is this going to be? So you look at your w here and you differentiate with what, respect to x. Keep the other ones as constants, just do them as what, as x. So now how is this going to, what, going to be? So I said 1, so you say 1, then I say 1 plus this function here which I have, that is y z over x. The whole thing has to be what, squared like this. That's the first thing. But then you have to differentiate the same function with respect to what, to x now. So differentiating with respect to x, I'm going to have, look, when I take the x in the numerator, I can write it as -1 like this. So I differentiate this. When I differentiate this, I just get, this will be -1, -1 when I multiply, so that will be y like this. Then z, x, and I reduce the power by 1, so that will be -2. So I can write this as y z. I bring it down, then it will be just x what, squared like this. So this is how I'm going to what, to write it. So you're multiplying now this by the negative y z over what, the x squared like this. So this here just is going to give you, so this is just going to give you, okay, so this is just going to be negative. So you have negative y z, then over, then you have x squared, then you're going to have 1 plus, squaring that there, you have y squared z squared, then divided by x what, x squared. This is what I'm going to get here. Okay, so getting this, but then also look, if I multiply the x squared throughout, there it will divide. So you just end up with having negative yz like that. Then divided by, you have x squared, then that will be plus y y squared and what, and z squared. So this is what I get. I keep this. Okay, so keep this, remember this. Then let's go, we find the next one, meaning we do now with respect to what, with respect to y. So partial of w, partial of what, of y now. So you notice that you'll be getting the same thing in the in the denominator, because you're doing the same thing in the denominator, you get the same thing, but what will be changing is what is going to be in the numerator. What will be changing is what is going to be in the numerator, because you are differentiating with respect to what, a different variable. So now here we're dealing with what, with x, so meaning this is going to look what, so what we said at first, which is just down there we had 1 plus z squared, or I mean y squared over x squared, like this. This is what we had. Then now you're dealing with what, respect to y, so what is going to go on top. So you see now here, differentiate this with respect to y, you remain with what, with z over what, over x, and this here is just can be written also as z over x the negative 1. So this is what is going to come here on top, so x z to the negative 1. But then I could want to reduce that into a form that looks better. So I know if I can multiply this by x squared on top, x squared, I multiply it there. So when I multiply on top there, I just remain with I remain with x z. So xz is what remains on top. Then down there I'm just going to have x squared, then I have plus the z y squared, and then z squared. So to have this good form, at least to have some uniform thing that I'm going to be having. Next, I do the same now, respect with what, respect to, so partial w partial of z now. So this is going to be, look at z, where z is, that is that there. So now because of that, when you differentiate with respect to z, you're just going to have, you have y over what, over x remain, which is just y to the x negative. And of course you multiply again by the x squared, so it will reduce. So this is just going to be in the form, this will just give you x y, then you have the x squared plus the y squared, and the z what, z squared, gonna be there like that. Okay, so we've done this for the partials. Now next you have to what, differentiate. So you have here, you have x written as t squared, yeah, here which we wrote x written as t squared, y as t squared, and what, z as 1 over t to the what, to the fourth. So that you have to what, differentiate now with respect to what, with respect to t. So meaning you're going to get dx dt. What is this going to be? So 2, so that would be 2 what, 2t, by just dropping the power and reducing it there. I go dy dt, and that there is going to just give me that will be 3 t squared, drop the power, reduce it by what, then you have again dz over what, dt. So this here, this, the z can be written as, that is t to the negative 4. So drop the power and reduce there, you just get negative 4, then t to the negative what, 5. So this is what I get now when I do this. The rest here is just going to be a plug and chug game, because you're just going to say dw over what, dt, and this here is going to be equal to, so the partial of w, partial of x, which we found earlier, was negative y over z, I mean negative y z, then you are dividing this by x squared plus y squared, z what, z squared, like that. Then multiply this by the dx, which is just 2 at 2t, plus you go for z, that was xz over x squared plus y squared plus z squared, multiply by the dy dt, that is 3t squared, plus the last part is we found x over xy, then you have x squared plus y squared z squared, and this then multiplying, you have that this is going to be negative 4 t to the negative what, 5, like that. So this is what you're going to get. Now the rest is just making it, trying to make it look beautiful. So how is this gonna look beautiful now? So notice now that these functions which you have x has, x is t squared, y is t to the cubed, and z is 1 over t to the fourth. So you need to replace this part. So you replace your x and replace your what, your y there. So you see what is my y. So my y is t to the cubed, then I'm multiplying that by what, by 1 over 4 over t to the fourth. So this here just going to give me 1 over t, but I can write that as 1 to the what, to the negative 1 like that. So then the negative sign will follow there. So this will be negative 1 over to negative t to the power negative 1. Then down there, the x squared. So x squared, I replace there. So I have t squared. So t raised to the power 2. T squared, I mean raised to the power 2 is going to be 2t to the fourth. Then plus the y, I replace there t cubed. What am I going to have? Okay, let me write it out. So that would be t to the what? T to the power 3, then I square that. Then z is going to be 1 over t to the fourth, then I square that. Notice that you are going to have the same thing in the in the denominator. So this is going to be in the numerator there. When you replace that, you just get negative t like that. Then down there, it's the same thing to the fourth plus. Then you have t cubed squared, then you have 1 over t to the fourth, then you have squared there, then you're multiplying by that 3t squared. Then this here is going to be on top, you have 5t, replacing that there, then you have t to the fourth, then you are going to have plus, this is going to be t cubed squared, then you have 1 over t to the fourth, then you're squaring this here, then you're multiplying this by negative 4 t to the negative 5 like that. Nice. So now next we clean this up. Oh, let's get rid of the dirt. So we clean this up. So this is going to give me, so I have that w dt is just going to be equal to the first part. So you see there's a negative 1 there and there's a positive 1 on the t there. So when they add that, they just give me what? Give me t. So that's going to be t negative 1 plus 1, which gives me 0. Anything raised to the power 0 is going to give me 1. So you get that you just remain with what? The 2 there and the negative sign, so you get negative 2 there. Then divided by, now I can evaluate what's there. So you have t to the fourth, then t cubed to the power 2, so that's gonna give us plus t to the sixth now. Then you have 1 over t, so I can write that as, so that could be to the negative 4, then distributing the 2 there gives me negative 8. So I'm multiplying this by negative, it's going to be like that, negative 8. Then I do the same here and this one here. You see that, oh, the 2 again is going to go remain with a 3, so that will be plus the 3, then over down there the same thing, 4 plus t to the sixth, then you have t to the negative what? Negative 8 like that. The last part, same again, you remain with a negative 4, so negative 4, then you have t to the fourth plus t6, then t to the negative what? Negative 8 like that. Okay, now from here, meaning you are gonna have this being equal to, let's clean what's down there. So negative 2, then you have what? You have t to the fourth. So look at this and this here, the power subtract, you remain with, that will be plus negative what? Negative 2 there. So I just have a plus, the same now for the rest there. So plus t to the negative 2 minus 4 over t to the fourth plus t to the negative 2 like that. So this is what you get here. But then notice that for this here, notice that they have the same what? They have the same denominator. So I can keep that, meaning I have t to the fourth plus t to the negative 2. Okay, there might not be enough space. Let me erase this part here. Okay, and write it on top here. So I have dw dt is just going to be, I keep the base, which is t in the denominator there, which is just t to the fourth, t to the negative 2. Then I add what is in the numerator. That's add negative 2 plus the 3 gives me positive 1. Then minus the 4, that is going to give me negative 3. So I'm just going to have negative 3 there. Okay, but then I can still clean this up. If I multiply, I can multiply here just to get rid of this negative 2, multiply by t squared. So I'll get negative both in the numerator and in the denominator, negative t squared, then there t squared, the 2 and the 4 are going to add, so you have t to the 6th, then there you just have plus 1. Since you subtract and they'll raise to the power 0, which will just give you 1. So this here is our dw, and we have used the chain rule for partial derivatives in order to find it. Well, if you're new, remember to hit the subscribe button, and we see you in the next one.